Welcome to Secure SQL Server Design, Tactics and Technologies. I'm Dan Mallott, and I'm a principal for West Monroe based out of Chicago. So, what's on deck? We'll have a quick introduction, and then I'll talk through how we can secure our database objects using items like tables, views, stored procedures. We're going to talk a little bit about role-based access and how we can use roles to secure our objects as well. Then we'll dive into SQL Server's built-in features and how and when to use them. Some of them are more useful than others, and we'll talk about that as well. And then lastly, we'll talk about when you can't start fresh. How do you apply these principles in your existing environment? Because changing things for the better requires some strategies.
So we hear about data breaches all the time, particularly recently with COVID-19. We've heard a lot about ransomware attacks, particularly against healthcare organizations. So got some facts here. So 95% of all breached records were government, retail, and technology. We're all technologists, so that certainly applies to us. Again, 95% of the data breaches are due to human error. That means that somebody like me or you or some other attendee today either did something wrong or didn't do something. The average cost of a data breach is expected to exceed $150 million this year. This is obviously a somewhat old statistic because I expect this will end up being higher simply due to the additional activity with COVID-19. Approximately 3.8 million records are stolen every day, and there is a hacker attack about every 39 seconds. So why are we here? For this reason, right? So what kind of data do we need to secure, right? We have different classifications. Personally identifiable information, so that would be, for example, my name, my birth date, potentially where I live. Protected health information, PHI. You may know it more popularly as HIPAA data. So this would be data about my personal health, whether that's the care that I got, my vital statistics, which doctor I go to, things that I've been diagnosed with. Data governed by GDPR. So GDPR has been enforced for a couple of years now. I think we're generally getting more comfortable with it, but it is still something that we need to consider. This is a big deal. In fact, just yesterday, one of the things that I work on for West Monroe is a threat hunting platform, and I was approached by one of the people who actually goes out and runs it, and they said, well, what exactly what data are we collecting? Because we have a European customer who's concerned about this. So this is something that we still have to be concerned about. Payment data, whether that's credit card numbers or ACH information. Obviously, anything that falls under PCI compliance is a huge thing that we need to worry about securing. Data that might affect a company's stock price or public standing. I think that we've all seen over the past certainly month, but even over the past few years, that things that leak out that are really potentially embarrassing or aren't messaged well can really affect a company's standing. And so it's important to make sure that we don't allow that to leak out easily. Industry trade secrets, that's fairly obvious. And that can be not just your data, but also your application code, your the business logic that you have in your database. Those things are important to make sure they don't leak out as well. And lastly, a little more personal, salary data. Maybe you don't want your salary data shared. Are there any others that you guys can think about? Okay. All right, so the first thing we're going to talk about here is how do we use the really most basic database objects that we have in SQL Server to help start securing our data. So we're going to talk a little bit about how tables, views, stored procedures. So how can we access or limit access to sensitive data this way? So tables, we'll start there. We can split tables to hold sensitive data in a side table that's more secure. There are obviously some drawbacks here. We can use schemas to separate tables with sensitive data, along with potentially logically organizing our database. I see way too many organizations that have everything under DBO, and really you're making it, number one, more challenging to secure your database, but also more challenging for someone new to learn it, right? So using schemas can help there. And then remember that access to tables can be secured individually as well, right? So if we think about splitting a table with sensitive data and a table with data that anyone can see, you can secure the table with sensitive data much more securely. If we think about using views, so views can be used to hide sensitive data in underlying tables, right? Because you're applying a SQL query on top of your tables. So you can apply masks to columns. You only include the columns you need. You don't need to simply select star. Remember that views are selectable and filterable and indexable sometimes. Similarly to tables, they can be good substitute for tables, particularly when you are talking about reporting needs or application needs. But do remember that views execute the underlying SQL, and so there may be some tuning implications there. So let's jump into a quick demo, and we can kind of check out how this works. So jump into my handy notebook, and I'll upload the notebook here as well as the individual scripts for afterward. So the first thing I want to talk about a concrete example of splitting tables. So in this example, I have a table without sensitive information. So we're going to talk about maybe some employees, right? A first name, a last name, and a hire date. So these are things that are relatively innocuous, right? Pretty much everybody in your organization can know these. But then we're going to have a table with some sensitive information. So this is maybe some more HR specific information. So security number, salary, birth date, right? These are things that you probably don't want widely available to the organization. And what I've done here is we have an ID on our table without sensitive info that is simply a primary key. I've identified it as an identity. And then on my table with sensitive info, I have the same ID column as a foreign key. In addition, putting a unique clustered index so that we're essentially enforcing a one-to-one relationship here. So go ahead and run this and create those tables. And then we can come into our database and see that it would help if I remembered which schema they're in. We now have those two tables. So that's great. We can use schemas in very much the same way. So a schema for non-secure data and a schema for secure data. And you'll notice I've used pretty much the same definitions here. And we'll go ahead and run this and insert some data as well. We'll look at how we do this later. Okay. So then how do we, this isn't going to be very friendly to use very often, right? Because there's some implicit join logic that we would need to write every single time. So this is where using a view can come in handy. So for example, I have a human resources view. Okay, so a couple of things to note here. Schema binding. Obviously, one of the big drawbacks with views is that if somebody changes the underlying table without updating the view definition, things break. Things breaking is bad. They're either in the minorly annoying side of things, a pager call at 2 a.m., or on the major side of things, potentially a resume generating event. So schema binding, we're not going to allow changes to the underlying tables without also changing this view. View metadata, so we can report, view metadata, so we can report metadata as though this were a table. And encryption, which allows us to hide the definition of the underlying query in system tables, right? So that I can't go around as a user who has access to the system tables, I can't simply go around and find out what this actually, where is this data actually coming from in this view, and potentially use that knowledge in a way that's bad. And so simply using our inner join, I'm hiding our social security number, because even for human resources, that's not something that we should be looking at very frequently, if at all. But human resources can certainly see my birth date and salary. And then to demonstrate this, I'm going to create a human resources user without login, just to avoid some stuff. I'm going to grant select on the employee view, and then I'll mask myself as the human resources user, select from that table, but also try to select the SSN from secure data.employee. And what you'll see is that while I can certainly get the data from the view, I'm unable to get the data from the underlying table. So we'll go ahead and run this guy. And you can see, yes, as planned, the select permission was denied on object employee, database, SQL Server LA, schema secure data. So this failed, but I was able to get the data that I had previously inserted. Any questions about that? All right, cool. So moving forward.
Yeah, no questions so far, Dan.
Great, thanks, Lori.
Uh-huh.
So views, tables, this is great, but we might have more complicated logic, or we might have an application where we don't want potentially an ORM generating queries that are really, really, really bad looking. And I'm not talking about just the ugly entity framework queries. I'm talking about things that bring your database to its knees at 7 p.m. when you're drinking a beer with your buddies at the bar, or having dinner with your family, or trying to relax with a book. So stored procedures are a great way to handle this as well. So if we use stored procedures and restrict access to only stored procedures, this is really, in my mind, the easiest basic way to handle security. So like the view, stored procedures will only return the data they need to return. You can apply business logic. Inputs are going to be surely properly sanitized. If you're disallowing direct access to the tables entirely, right? The one big thing to note here is that using stored procedures for data management is going to have an impact on your application developers. Now, whatever they tell you, most ORMs have the facility to use stored procedures for data access. Don't let them tell you anything different. Or if they're really concerned about it, they don't want to use an ORM, or they are concerned about the performance or something like that, you can use something like Dapper, which essentially is simply writing your own ADO.NET access, but it plays really well with stored procedures. And so we can look at an example of this as well. And so I'm simply taking the same logic that I had in my view and encapsulating it in a stored procedure. Now, realistically, if this were a stored procedure that I were writing for a real application, I would likely put in some parameters so that to be able to filter it dynamically, or at least filter it on the employee ID, maybe the employee last name, to make this a little bit more general purpose than a get all. But in terms of a quick demo for a talk like we're having here today, you can see the general picture, right? So we have our DBO get employees procedure, and then I'm going to grant execute to my human resources user and execute the stored procedure, and then we'll see some other data, right? So again, as a reminder, I never gave the human resources user the ability to access the underlying table, but you can see that the stored procedure ran just fine, and I was able to see the same data that I did with the view. Are there any questions about that? Anything that you guys want to see again?
We have one question, Dan. Is there performance overhead with using this setup versus direct table access?
So there should not be performance overhead in your database. In fact, because you are more tightly controlling the SQL that gets generated using a stored procedure, you should be able to control the performance much better and see much more consistent and easily tunable performance. One thing I would caution that you have to watch out for is parameterization. That can bite you with this approach, but it could bite you with the direct table access approach as well. From an application side, really you should see very similar performance no matter what you're doing to get your data. If anything, if you're using an ORM like Entity Framework, this will be slightly faster because the ORM doesn't have to do the work to generate the query. It simply executes the stored procedure. Does that make sense?
I think so. It's me. Follow up so far.
Cool. All right. We'll keep moving forward then. So next, and then next up, we're going to talk about what's my role, right? So there are a lot of objects we need to manage security for. We just talked about tables, splitting data between tables, writing views to encapsulate that, writing stored procedures, potentially a lot of stored procedures. So how do we manage security for all these objects? And the answer is database roles, right? So roles allow you to logically group permissions. So you saw a bit earlier that I was granting individual permissions to individual objects, right? That gets really frustrating really quick, and it's kind of painful to manage. But we can group these using database roles. Anyone who's worked with SQL Server is probably familiar with some of the main roles already, right? DB owner, DB data reader, DB data writer, sysadmin, security admin, server admin. It's likely that some enterprising soul made a DB executor role at some point to mop up that sort of missing piece, right? And so these are predefined roles with predefined sets of permissions, right? So if I am granted DB data reader on a specific database, I can now query every table in the database. Likewise, if I am granted DB data writer, I can now write to every table in the database. That's probably not great. So should we be satisfied? Absolutely not. These are, the built-in roles are very broad-based, and they're meant to be, and not suitable for environments where more detailed permissions are required. So you might use DB owner in a development atmosphere, but in your test database or in any database where you have production data, that's probably not the greatest plan, right? So we can define our own roles, that group permissions logically. We can mix permissions to give each role only the permissions it needs. This is called the principle of least privilege, and from a security perspective is considered best practice. And then we can assign users to roles based on their membership. This actually integrates in, if you're running in your SQL Server on Windows, it integrates really well with what the system administrators already do with Active Directory. So most Active Directories have a lot of groups and they can use it to control access. We can actually assign our roles to Active Directory groups instead of individuals. And so when we need to revoke access, simply remove the user from the role if we're using SQL logins, or if we're using Active Directory, removing them from the group, and they're done. They can no longer access. And so this is a really good way to think about securing your data and grouping up access permissions. So let's take a look at a quick demonstration. So pop back over here. So I'm going to create a role for my human resources users. So my role, human resources users, and I'm going to give them some finer grained permission. So execute on our stored procedure that we made earlier, select on the non-secure table. These are human resources personnel, so we're going to give them access to the secure data as well, employee, but I'm going to specifically deny select on the secure data employee SSN column. So even though they can select everything from employee, they can't see anything they can't see the SSN column. And then for demonstration purposes, create a human resource user 2. So remember, we had the human resource user up above. Add this user as to the role. And then we'll execute some test queries down here and see what happens. Let's go ahead and run this. Okay, so interesting. You can see all my commands completed successfully. If we look at the output from the notebooks, which can be a little strange here. So execute as user, that worked well. Exec my stored procedure returned 1 row, good. My non-secure table, 1 row. I got a select denied for selecting star from my secure data. And we'll look at why that happened in a second. And then when I selected the columns that I'm permitted to select from my secure, 1 row. So that's good, right? And you can see the data came back as we expected. So now let's roll back up and see. So when I did select star, the select permission was denied on the column SSN of the employee. Okay, so you can see that my deny select on SSN worked, right? And I can no longer set the side effect. I can no longer simply select every column from the table. If there were more columns that I had denied select on, then you potentially have some whack-a-mole to do. But I can no longer get at that data just by my role. So any questions about that? I saw there's a big fan of using roles in AD for
Yes.
security. Yeah, that's
Yeah.
so before I was a software engineer, I was a DBA, and I took over an environment where everyone had a SQL login that happened to be a SQL happened to be an admin on all of the servers, which was super scary. And that is the approach that I took almost immediately. And sorry, Lori, was there another question there?
No, just a comment.
Yeah.
I completely agree on the AD for security. Yeah, run roles.
Yeah, and it really comes down to if we think about it, it really comes down to, look, this is what we're using for security for our workstations, for our servers. There's no reason not to also leverage it for our data, at least for the access piece, because this is like, why reinvent the wheel? Why have another place to go manage it, right?
Yeah, exactly. Yep, agreed.
Okay, any other questions? We're gonna jump in. Gonna take a detour into some other things with SQL Server here. So
Yeah, no more questions at the time.
Okay,
great.
Great. So we spent quite a bit of time talking about how we can use some of these more basic methods to help secure data, help control access. But let's talk about some of the more security-focused built-in features that SQL Server has that we should really at least know about, even if we're not necessarily using them. And so I'm going to talk about 5. And these are available in, I believe, at least going back to 2016, and I believe before that for some of them as well. So those are Always Encrypted, row-level security, dynamic data masking, transparent data encryption, and SQL Server Audit. And so we're going to start with Always Encrypted. So Always Encrypted is sort of an interesting feature to me. Essentially, it's a feature that allows you to control encryption inside your client application and never share the key with the database engine. So essentially, imagine I have an application, it encrypts the data, writes it into SQL Server, and then anyone reading that column only sees an encrypted binary string. Why would you want to use it? Look, this is a great way to protect sensitive data by removing the ability to read it entirely from the database. So you have to access the data through the client application, or at least have the decryption key. Drawbacks, not all clients support Always Encrypted. If you are encrypting via the randomized routine, which is recommended, then you cannot use that data for joins or other equality operations. So there's a potential for, like, number one, some annoyance, but number two, some major performance hits there. And then likewise, same idea, any column encrypted can't be updated using the database engine directly, right? So you're taking control away from the database engine, which SQL Server is really good at the things it does, and so this may not be a very good choice. And then the last one is that if you're using Always Encrypted, columns must use the any one of the binary 2 collations, and I believe that you have to be use the same binary 2 collation on all of your Always Encrypted columns. I do not have a demo for this because I don't think this is actually a particularly useful feature, but it is there, and you may have a use case where it makes sense. So next, row level security. Row level security, and So this is where our group membership and roles comes into play as well. So this allows you to use either group membership or execution context to restrict access to data rows in a table that uses a table valued function as a where clause. This happens transparently, and it works really well. It also, again, there may be some performance implications. I'll get to those in a second. So why do you want to use this? It's transparent to consumers. You can centralize some security logic, and this can be important. I worked on an application a couple of years ago where it was a multi-tenant application within a single database, and we had both a web application and Power BI reports consuming the data. And so row level security was a really easy way to get that going. And then this is something that's been available in SQL Server for quite a while, and so there's generally broad compatibility. There's a pretty important caveat there that I'll get to in a second. As I mentioned above, it does use a table valued function, so there may be some performance implications. Partition views are not supported. Kind of makes sense, right? You can't create an index on a view. This one's super weird. You can't create an index on a view on top of a table with a row level security policy in force. So yeah, that one's just that one's a little strange, and it's a limitation. And then rather important for anybody on 2016 and newer who's using this feature, temporal tables do not automatically inherit the security policies of their parents. And so this can trip you up, right? So you need to make sure that rather than just letting the engine automatically generate the temporal table definition, that you actually take control of that for yourself, so that you make sure the security gets applied properly. So we're going to take a quick demo and look at how this works. And so this is a two-step demo. So we're gonna, first step is enabling row level security. So creating a schema to store our security objects. This is a general best practice organization thing. In case you hadn't figured it out, I really like schemas. We create our filtering function. This can be reusable, so this is great. In this case, it's a simple function, takes in a user ID, returns a table with schema binding. So this removes the need for additional permissions on security objects, which is kind of important, right? I think we've all gone down that rabbit hole once or twice. And this is the sort of general shell of a simple function, right? So return select one, because we really don't need anything as the result, where, and in this case, I'm using the session context, equals the user ID that's passed in. And we may also want to filter by login if you have multiple logins or applications. That you can get more complicated here. Again, it's a table valued function. Don't go crazy. And then we actually apply this security or create a security policy on our table using this function. So what we're doing is I create this security policy, add a filter predicate. And so this is simply the name of my function, the customer ID, which is the ID that I want to pass in to do the matching on my sales.orders using the wide world importers database. And then, so this filters my returns, and then this block predicate, which is nice. So you'll notice it's the same function call on sales.orders after insert. What this does is it allows me to block the ability of anyone to insert data that is any other than my anything else than the user ID that would be allowed to select, right? So I can't go in as user ID 1 and insert a row with customer ID 2. And then I'm going to go ahead and turn this on. So we'll get that going. Okay, that all worked. So first step for demonstrating this, we're going to create a user without a login again. You'll notice I'm using this a lot just to simplify things. It's not great to have a lot of these hanging around in your database, so use with care and sparing. I am going to grant the all credibilities on the sales.order. And then as another best practice, I'm going to deny update on the column that we're filtering on. So the reason we're doing this is to prevent a user from not only updating data so that they can no longer see it, but also updating data they can't see into data they could see. We're going to execute as our temporary user. In this case, I'm using session context. So if I were connecting from .NET, I could set the session context there. Likewise, in a report, I could set session context similar to this. I'll get the data, and then just for demonstration purposes, I'll change my context to so it's user ID 5 instead, show that we get a separate set of data. So we'll go ahead and execute this guy. Yep, and you'll see in my first set, I get all of customer ID 4. And then in my second set, I've got all of customer ID 5. So any questions about that?
We have two questions, Dan. One is dynamic data masking is also used apart from encryption. Which one is the best for security of the application data?
So I'm going to talk about dynamic data masking next. So let's hold that question and I'll try to address it as we go. Okay,
great. The other is index on a view. So you are talking about index views, which themselves have a lot of restrictions, right?
That's correct. So this is if you have a table that has row level security applied to it, any views that use that table cannot have indexes applied on them.
Okay.
And so I couldn't tell you why, but I think it's, if you think about it, because of the way that that SQL Server is kind of handling the row level security underneath, and the fact that the index would apply to a different object, I think that's kind of where that disconnect happens there.
Yeah, okay. And we have just one more question. Would you be concerned about securing the session context, such as users shouldn't be allowed to change it?
So I think the thing with the session context, so a couple of things. I would restrict the ability of anyone to simply execute that stored procedure. Ideally, you are going to have some code in either your application or your report that handles that transparently to the user, where it's not something they're even able to change. So, for example, if you think about a web API, ideally in your controller, in your .NET code, you are reading the identity of the user and setting the session context all in that code, and there's no opportunity for the user to change that. If you have a situation where people are accessing the database, whether it's through Azure Data Studio or SQL Server Management Studio, it probably makes more sense to think about instead of using the session context to maybe use like the logged in user or something like that. And that's going to make your table valued function more complicated, right? Because you're probably going to have to go look up what they're allowed to see somewhere. But it will prevent anyone from kind of messing with a session context or something like that, like we're using here. Does that make sense?
Yeah, I think so. Yeah, he says thanks.
All right, cool. All right, so you can tell I'm not in great practice here because we're kind of pacing slow, but that's okay. I'll get through the rest of this here. All right. So great segue with the question on dynamic data masking. So I'm going to talk a little bit about what dynamic data masking is. I'll get into the using that instead of encryption here in a second as well. So dynamic data masking applies a masking function to data when it is read by non-privileged users. Like we were just talking about with row level security, this process is transparent. Why would you use it? So a couple of reasons. Rather than relying on application level filters, you can specify a mask that applies to all queries. This is the case where I would use it instead of something like column level encryption or always encrypted, because this is going to be a way where we aren't going to have to rely on drivers or clients or keys. We're still able to use the data, the underlying data, for equality and join operations. And I think that this is sort of generally better. There is one caveat there that I'll talk about in a second. Again, like row level security, really broad compatibility with other SQL Server features. And you can write your own masking functions, which is great. There are also a couple of default built-in ones. Some drawbacks, and this applies to using this instead of always encrypted. So obviously columns encrypted using always encrypted cannot also have a mask applied to them, right? Because you've taken away the ability of the database to read the underlying data. Okay, that kind of makes sense. You cannot apply a mask to a computed column unless one of the underlying columns is also masked. So I don't know for all of you how frequent or widespread the use of computed columns is in your databases, but this could be something to consider. And then this is where using a masking function or dynamic data masking can maybe not solve your protecting the data problem as well as you'd like. It may still be possible to derive the underlying data by applying a clever or not so clever where clause. So if you have a situation where you are dealing with some sensitive data that is filterable in like some sort of numerical order or using some sort of like clause, this is where like it might just be better to deny access to the column entirely, or think about some other options there. So real quick, I'll jump into the demo. And so I'm going to create a new table for this. We're going to kind of start fresh. So masked, yeah, so my table, okay, ID, first name masked with, so we're going to look at a couple of different ways to do masking here. So in this case, I'm defining how I want my mask to look. So I get my first character, 6 X's, and then nothing remainder. Great. My email, I'm simply going to mask with the email built-in function, and then phone, I'm going to let SQL Server just do whatever it thinks it should do with this by default. So insert values Dan Mallott, dmallott@wnp.com. This is indeed my office number. Obviously, I'm not in my office right now. And then we'll take a look at that way that table looks. And then we will also take a look using a test user. And we're gonna show, that we can actually get at this data. So we're gonna run this real quick, see what happened. So this is, now you can see what I did. Probably actually run that piece of it. Apologies. Actually, just need to run this block. There we go. So we've accidentally input some extra rows. So this is, again, I can see the data, see how it's masked, and you can see that I can still select out of it and find specific data. So are there any questions about that specifically? I want to make sure that I answered the questioner with the security, always encrypted versus dynamic data masking question.
No additional questions, Dan?
All right. Great. Okay. Gonna keep us moving here.
Okay, great.
So last thing that I have a demo with, transparent data encryption. So this is the practice of encrypting the data at rest. This includes backup files taken using SQL Server's built-in backup functionality, which is great. So this provides an additional level of security for your data at rest, making it more resistant to being compromised if somebody goes into your data center, pulls the exact hard drive out of the rack and steals it. However, the important part here is that the encryption is also extended to backups. And so everybody's storing their backups in an offsite location, right? Potentially Azure Blob Storage, potentially, at something like Iron Mountain. And so encrypting your backups is really important. So there are some drawbacks. Number one, your server OS and your administrators probably already cover this need, whether it's via BitLocker or if you're in Azure, everything is encrypted under the covers anyway. The ability to read the data is entirely dependent on the certificate that you generate, and that extends to the backups as well. So if you lose the certificates, your backups also become unreadable. That's bad. The good news is that transparent data encryption integrates with several key management providers, including Azure Key Management. So this is, there should be some sort of key management in your organization already. If there's not, bug your administrators about it. They know. And then the last, which is a big drawback and requires planning, is that instant file initialization is not available when using TDE. So if you rely on instant file initialization, you aren't going to be able to use transparent data encryption. And if you want to use transparent data encryption, conversely, you're going to have to plan your database size changes. Ooh. Excuse me. Let's just jump into a quick demo on how this works. This is really easy to set up, and I'm going to show you a really basic way of setting it up. I've actually never done this on this particular Docker container, so we're going to have to do this. So you need a database master key. Use a better password than this. Going to create a certificate based on our master key. So this will be the thing that we're actually using to encrypt. create a database encryption key, and always use AES 256 or stronger. And then all I have to do is alter my database and set encryption on. So we'll go ahead and give this a run. And yep. So depending on the size of your database, this step takes a while. Makes sense. You're encrypting all of the data on the hard drive. So obviously not something to do during business hours or during high use times. You'll notice that SQL Server helpfully noted the warning, a warning at us that the certificate used for encrypting the database encryption key has not been backed up, right? So this is the same thing that I was mentioning about don't lose the certificate. Any questions about that?
No questions, Dan.
Great. Okay, so I see we're running a little short on time, so I'm gonna kind of just move forward here. Last thing to know about SQL Server Audit. This allows you to log events, details about events, when they happen on a server or database level. So that can include things like permission changes, object access, even more granular, a specific user, group of user accesses data on a specific table. So this can be really useful for HIPAA auditing purposes or financial auditing purposes. Why do you want to use it? It's a built-in way to log events and ensure that security policies are being followed. It can also help detect attacks on the server. So for example, a high number of failed logins may indicate a malicious attack. The major drawback, anyone with sysadmin can turn it off. So that may or may not be a good thing. And then events are logged to Windows Event Log or a file, both of which can be difficult to access easily. And particularly, they're not the most straightforward things to query, which goes into our last drawback, which is that by itself, it doesn't perform any active alerting. So you actually have to set up some secondary alerts. Okay. I'm going to do is a quick chat about retrofitting here. So great stuff. What do I do with my existing database? Okay, so things you can do today, and by today I do mean Monday. So enable transparent data encryption. Yes, the OS handles it. Yes, it's just a checkbox item in Azure, but it's worth doing it for no other reason than your backups are encrypted, right? Particularly if you are storing your database backups in S3 or Azure Blob, please use this. Number two, take an inventory of your users and your permissions. If you don't have it already. If you're gonna go to a role-based system, you have to do this because you have to design the roles. But this is also gonna help track down anybody who's got sysadmin and shouldn't, which is probably at least one person in the finance department. Talk to your boss about conducting a security audit. That can be either with your internal security group or with an external partner. See what and talk to them about what to do with the results, right? Because you're gonna have some red things, some yellow things, and some green things, and that's just more work that has to happen. Talk to your security and compliance people. They're probably doing a lot of things around this already, but they're also gonna have ideas about how you can help. And they're gonna love that you came to talk to them in a way that wasn't like, why did you take away my access? And then lastly, talk to your application developers about how they consume data. Just going out on a limb, most likely they're using some sort of ORM, whether it's Hibernate or Entity Framework or Dapper or Active Record or whatever it is. Applying some of these security changes, they're going to affect them, but talking to them can help you understand what object changes you can make without affecting application functionality, right? And without giving them more work, because there are going to be some. And then your application developers may not be aware of some of the features that are available as well. I saw yes, yeah. In 2019, it's available with standard. Yes, in older versions, it does require enterprise, which is a major drawback for transparent data encryption. It's a major cache drawback anyway. And then next, start planning some deeper changes. So, over maybe a 6-month period, engage in planning, stronger role-based access, views or stored procedures, schema, SQL Server audit strategies, where to use dynamic data masking, where to use row-level security. Execute. Some projects may be done transparently, great, but make sure that everybody knows it's happening so that you don't inadvertently break somebody. And make sure that you have a solid test plan in place. Don't just make changes to production, as these can and sometimes can and usually are resume generating events, which are bad. So I am just over time. Feel free to throw in any questions. I'll throw up the slide of who I am real quick. Any questions, Lori, that came in?
No more questions, Dan.
Okay, great. And then, as I mentioned at the end,
You have one, just popped in.
Okay.
Could you share a success story of an ORM in place, e.g. Hibernate and data access done through stored procedures only? In my world, Hibernate generates the tables itself.
Ooh, that's the subject of a whole other talk. So a quick story. The way that, and so this is sort of a similar to this is the same application I was mentioning earlier, where we had to use row level security because we were accessing both from the application and from Power BI. We used SQL Server data tools to build our database model and deployed it that way. And then also wrote stored procedures. We did use Entity Framework in that application to handle the data access, because there was certain data access that we were using just with CRUD. But we simply used we used model first, so that this is available in Hibernate as well. You don't have to let Hibernate generate the tables. In fact, I would recommend not. And essentially what we did was we wrote models based off of C# classes, models based off of our what we had in SQL Server data tools in terms of the actual table definitions, and then wrote up our access layer or a repository layer that, okay, you need data from this. It just simply executed the stored procedure, and it worked really well. It performed really well. And that is a really high level explanation of that. But if you come to, I don't know if the agenda for Summit has been released or not, but if you're coming to Summit, I'm going to be speaking more on methods of getting data out of SQL Server than that. So sorry, that was really, really quick and really broad, but it is certainly possible. Step one would be don't let Hibernate or Entity Framework generate tables for you.
Okay, great. No more questions.
All right, great.